War invoice helper runs overnight. One customer record is missing the payment terms. The prompt says, summarize the invoice and flag late payments. The large language model does not say, I cannot know that. It invents net30, returns valid JavaScript object notation, or JSON, and your job runner accepts it. Now the account team sees a late payment warning that is simply false. The retry system makes it worse, because every retry returns a slightly different confident answer. Nothing crashed. That is the scary part. The prompt failed, but it failed as if it succeeded. The beginner prompt usually describes the happy path only. Here is the input, produce the output. That works in demos because the example is clean. Real inputs are not clean. A field is missing. The user asks for the best plan without saying the goal. The task requires information the model cannot access. If the prompt does not name these conditions, the model still tries to be helpful. Helpful for a model often means filling gaps with plausible text. Your code then sees a normal response, not an error. This is why prompt error handling matters. Your program can only handle the failures the prompt admits can exist. The core idea is simple. Give the model a failure vocabulary before you ask for the work. I like 4 statuses: OK, missing data, ambiguous, and impossible. Missing data means the model knows what is required and it is not present. Ambiguous means more than one reasonable interpretation exists. Impossible means the request cannot be completed under the available context, tools, permissions, or constraints. Each status needs one output shape, not a paragraph of apologies, a parseable shape. Then failure becomes data. Your application can branch, ask the user, fetch a field, stop safely, or log the reason instead of pretending every response is an answer. Build it in 3 moves. First, define the contract. The model must return exactly one JSON object with a status field. Second, define required fields for each status. For missing data, return needed fields as an array of field names. For ambiguous, return exactly one clarifying question, not 5 questions, not a survey, one question that would unblock the task. For impossible, return reason and blocking constraint. Third, make your code branch on status before using result. In plain Python, that is a function like handle response dict, that if status equals OK, continue. If missing data, request fields. If ambiguous, ask. If impossible, stop and show the reason. Imagine a local email reply helper. The user says, write a reply to Sam about the problem. The email thread only says, this is still broken. A naive prompt drafts a confident apology about a refund, because that sounds useful. With prompt error handling, the model returns status missing data and needed fields, customer issue, desired resolution. If the thread says the issue, but the user asks, make it better, the model returns ambiguous with one question. Should the reply be more apologetic, more concise, or more firm? If the user asks, include Sam's private account balance, and that data is not provided or permitted, the model returns impossible with a reason. No guessing, no fake access. There are limits. The model can still put the wrong status on an edge case. Your prompt reduces ambiguity. It does not remove uncertainty from the universe. Keep the statuses few, because 10 failure labels become their own classification problem. Do not write soft rules like, try not to guess. Say, if a required fact is absent, return missing data. Also validate the response. If your code expects JSON, parse it and reject extra text. The trap most tutorials skip is retries. Retrying an impossible or missing data case without changing the input just burns tokens and may eventually produce a hallucinated success. This is not just prompt polish, it is part of the agent harness. An agent is a loop with a goal, a role, tools, permissions, state, and a termination rule. Stuck states tell the loop when not to continue. Missing data can update state with a pending field request. Ambiguity can pause for the user. Impossible can terminate with a safe explanation. Later, when we add tool calling, this same pattern prevents hallucinated tool calls. When we add memory, it prevents the agent from pretending it remembers facts it never stored. Reliable agents need boring contracts like this. Try this safely on your own machine. Make a tiny Python script with 4 strings, a complete request, a request missing required facts, an ambiguous request, and an impossible request. Send each one to whatever model API, application programming interface you already use. The provider does not matter. The shape is the same. Messages in, text out. Put the failure contract in the system or instruction message. Parse the return JSON with JSON.loads. Then print one of 4 branches. Use result, ask for fields, ask the clarifying question, or stop with the reason. If one case guesses, tighten the contract.
3 beats to keep. First,
Prompts fail in predictable ways, missing data, ambiguous asks, and impossible tasks. Second, define one output shape for each failure so stack becomes parsable. Third, your code can only handle the failures the prompt is allowed to return. This is small, but it changes the tone of the system from always answer to answer when valid, pause when not. Tomorrow we keep building the foundation layer for reliable agents. New Agent Foundations episode daily. The paid libraries at aislabs.ai go deeper with production patterns, templates, and implementation walkthroughs.